Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to see a new problem which is based on integral of the form 1 upon a plus b sin x plus c cos x dx. Let us start with problem number 3. Integral dx upon 1 plus sin x plus cos x. In the last two videos, we have seen the form 1 upon a plus b cos x and also 1 upon a plus b sin x. For that, we have seen the substitution of dx, sin x and cos x. Now here you can see dx, sin x and cos x have appeared in a single sum. Therefore, we are going to use all these three substitution and at the same time, we are going to put tan x by 2 as t. Substituting tan x by 2 as t. The value of dx will be 2 dt upon 1 plus t square. The value of sin x, we know it is 2t upon 1 plus t square. And the value of cos x is 1 minus t square upon 1 plus t square. Let us substitute these three values in the given integral I, meaning the value of dx will be 2 dt upon 1 plus t square. Similarly for sin x and cos x. This will give you integral 1 upon 1 plus 2t upon 1 plus t square plus 1 minus t square upon 1 plus t square. So this is the value of sin x and this is the value of cos x into the value of dx is 2 dt upon 1 plus t square. Now here in the denominator we have three fractions. Considering the LCM as 1 plus t square, this will give you integral 1 upon 1 into 1 plus t square is 1 plus t square plus 2t plus 1 minus t square divided by the whole 1 plus t square. By doing this step, you can directly cancel 1 plus t square. Previously, you cannot because 1 plus t square is only meant for these two terms. In this step, by taking LCM, we have taken 1 plus t square for all the three terms into 2 dt upon 1 plus t square. Therefore, 1 plus t square will be cancelled. Further, we have integral 2 dt upon 1 plus t square plus 2t followed by plus 1 minus t square. As you can see, plus t square and minus t square will be cancelled and taking 2 outside, which is a constant, we have dt upon 2t and 1 plus 1 will give you 2. Again 2 can be taken common from the denominator. That will give you 2 into dt upon t plus 1 and that 2 can be written here which will be cancelled. Therefore I will be integral dt upon t plus 1. Therefore I is equal to integral dt upon t plus 1. Now to find integration of 1 upon t plus 1, I can compare this integral with 1 by x. As x is a linear term, similarly t plus 1 is also linear term. Integration of 1 by x, we know it is log x. Similarly, integration of 1 upon t plus 1 will give you log of t plus 1 plus c. Resubstituting t as tan x by 2. Therefore, I will be log of tan x by 2 plus 1 plus c. This is our final answer. I hope friends you have understood this problem. Thank you for watching this video. Stay tuned with Ekeeda and subscribe Ekeeda.